All right, good morning. 3.3 equations in y equals mx form. Today's goals: I can identify constants of proportionality. I can write direct variation equations. I can use direct variation to solve problems. First thing we have to do is we have to define what direct variation is. And direct variation is going to be, let's see. There we go. It's going to be an equation. It's a linear relationship with a constant ratio. So when we learned about how to figure out if information is proportional, that was when we did our constant ratio of y to x. If a linear relationship with a constant ratio of y to x equal to the slope m. This means that y varies directly with x. These relationships are proportional linear, which means their graphs go through the origin. So remember, the origin again is that point 0, 0, or in the graph it's right in the middle. So y varies directly with x. They are proportional and they go through the origin. All right, what does m represent in direct variation? It's the constant ratio. The constant ratio we found was y divided by x. So I want you to write y divided by x. It's also, m represents in direct variation the slope. So remember, we had our formula of y minus y over x minus x. Okay. It's also your constant of variation and constant of proportionality. All of them would be correct. So first we're going to be determining, we're going to do a few that we need to determine if the table shows direct variation. All that means is it proportional? Proportional. Oh, getting better at this. Oh. So is it proportional? So what we have to do is we need to figure out if it has a constant ratio. So if it does, we're going to take our y and divide it by our x. So 0.41 divided by $5, and that equals 0.082. So 0.082. I'm going to do the same thing for all of these. So 0.82 divided by 10. Remember, you take your y, so your y, and you're going to divide it by your x. And you need to simplify it down, and that's going to get 0.082. So right away, I know that it does show direct variation because it is proportional. It has a constant ratio. So if it is, it says, if so, find the constant of variation. So there I have to divide my my y by my x, and this right here is going to be my constant of variation. But I need it to be in a fraction form. So what I want to do is I want it to be in fraction form simplified. So I'm going to put it back into a fraction. So remember, if I have 3 decimal places, that means I have 3 zeros in the bottom. And then my top number goes on top, 82, and reduce that down. That would mean 41 over 5. 100. I cut both of them in half. So this is my constant of variation. I could have also taken, come in. All right, sorry about that. I'm going to go here. I'm going to move on to the next one, and I want to figure out if the table shows direct variation or if it is proportional. So again, I'm going to take the y and I'm going to divide it by the x. So 154 divided by 11, 167 divided by 12, 180 divided by 13, 193 divided by 14. When I reduce them down, 154 divided by 11 is going to get me 14. This one, 167 divided by 12, is going to give me 13.9. So right away I know that they are not proportional because these two numbers, I don't even have to do these other ones, are not the same. If they're not the same, there is no constant of variation. It is not proportional. It does not show direct variation. Okay, the next one is going to be, this is our direct variation equation. We're going to have a y. We're going to have a y equals m. Sorry. Our m is going to turn into a number, so that's going to be one of our slope. So say our slope was 10 over 3, and then times x. It becomes a number, and our x also stays the same. Our x is our input. This is going to be all direct variation equations are going to be in this form. So when we have a graph, the way we know that if it is direct variation is it's going to go through the origin right here. Let's see if I can highlight it a little more. Okay. This right here shows, oh man, it's going to be, it's our direct variation equation. Here, because it goes through our, here, it shows that the relationship is, it's a proportional relationship. Oh, go down here. Y equals K, oh, not K. Y equals mx. If I wanted to figure out what m was, I can actually change it and divide y by x. So I'm going to put some points in here. So 0, 0 I'm not going to use because that would be just 0 divided by 0, 0. But I do have, let's see, 1 and this point right here. I'm going to use that point. So I have 1 as my x and 3 is my y. So if I were to wanted to figure out what my m was, I could do y divided by x, and that would get me my m. Alright, the amount of money Robin earns while babysitting varies directly with the time as shown in the graph. So determine the amount that Robin earns per hour. So first, because I have this here, it varies directly. That's going to tell me right away that it is direct variation. I will get good at this. Okay, direct variation. Now, earns per hour, that's going to be your rate of change. So remember, your M is going to be your Y divided by your X. So here I need to find a point, and I need to do the Y divided by the X. So for this point here is 2, and up, what's in between, halfway between 10 and 20, that would be 15. So if I pick this point, 215, I'm going to put in here what Y is. So 15, I'm going to divide it by 2, and that's going to get me my what I earn per hour. That's a terrible. Okay, so 15 divided by 2 is $7, or 7.5. Well, 15 represented the money, and remember here is per, and 2 represented the hours. So if I reduce this down, it would be $7.50 per hour. So let's try a few. Your assignment is going to be 1, 5, and 6. Just start this assignment. We're going to hold off on the flippable for right now. We'll talk about this in class.